Hello, everyone, and a very warm welcome. Have you ever just stopped and wondered, how did the phone in your hand get so incredibly powerful? Well, its story, believe it or not, starts almost 80 years ago. Today, we're going to dive deep into that exact journey. We're talking about the generations of computers. Now, this topic isn't just super important for your exams, it's also going to help you really understand how technology has evolved. So, are you ready? Let's get started.
So yeah, that's the big question, isn't it? How on earth did we get from computers that took up an entire room to this sleek little smartphone that just, fits right in our pocket? It's a huge leap. This journey from those room-sized giants to these pocket-sized powerhouses, it's honestly one of the most incredible stories of human innovation. So let's trace this evolution step by step. Okay, so to make sense of this whole incredible story, we actually break it down into 5 distinct generations. Just think of this timeline as our roadmap for today. Each of these generations marks a revolutionary breakthrough. I'm talking about a single invention that completely changed the game, making computers smaller, faster, cheaper, and way, way smarter. So let's start our journey with the very first one, Generation 1. All right, kicking things off with the first generation. You got to imagine, this was the era of true pioneers. The whole idea of a modern computer was just taking its first baby steps. And right at the heart of these early, massive machines was a piece of tech that honestly seems ancient to us today, the vacuum tube. So this slide right here, it perfectly captures not just the tech of the first generation, but also its huge problems. The core technology, as you can see, was the vacuum tube. Now, I want you to picture this. Thousands and thousands of these fragile glass bulbs, and each one is glowing hot, just like an old-fashioned light bulb. That's exactly why these computers were absolutely enormous. We're talking filling up entire rooms. And they were so slow, guzzled up massive amounts of electricity, and generated so much heat, they literally needed industrial-strength cooling systems just to stop them from melting down. Crazy, right? And because of all that, they were unbelievably expensive. Now, listen closely because this is important for your exams. Remember these limitations: size, speed, heat, and cost. These are the exact problems that the next generation was born to solve. This is a classic question, so make a mental note.
And here are 2 names you should definitely remember: ENIAC and UNIVAC 1. These are the big, famous examples from this era. You'll often see these pop up in multiple choice questions, so it's a good idea to just jot them down. I mean, for their time, these machines were, without a doubt, the most powerful calculating devices on the entire planet. So you've got these massive problems, right? Size, heat, cost. It's a mess. How do you even begin to solve them? Well, the answer came in the second generation. And let me tell you, it wasn't just an improvement, it was a full-blown revolution. And it was all thanks to one tiny little heroic invention, the transistor. So what exactly is a transistor? Well, think of it as this tiny little semiconductor device that could do everything a big, bulky vacuum tube could do, but a whole lot better. It was smaller, it was faster, way more reliable, and it used just a tiny fraction of the power. Seriously, make no mistake about it, the invention of the transistor was the single biggest leap that basically kickstarted the entire modern electronics era we live in today.
And wow, just look at this table. It really shows the night and day difference the transistor made. Check out that jump in speed. We're going from milliseconds to microseconds. Do you know what that means? That's 1,000 times faster. Computers weren't room-sized anymore. They were getting smaller, more like the size of a few large cabinets. And the heat? Phew! The cooling problem was massively, massively reduced. This comparison right here is perfect for your revision because it just perfectly sums up that incredible leap from Gen 1 to Gen 2.
But you know what? The revolution wasn't just about the hardware. On the software side, things were changing too. For the very first time, computers started using something called magnetic core memory. You can just picture it as a grid of tiny little magnetic rings that could store information even when the power was switched off. Super useful. And programming got a whole lot easier. Instead of typing out endless, painful strings of ones and zeros, programmers could now use early high-level languages like Fortran and COBOL. These were much closer to actual human language, which, as you can imagine, was a huge, huge step forward.
Okay, so the second generation was amazing, right? It made computers smaller, but engineers, being engineers, were already thinking ahead. They were asking the next big question. They were like, okay, transistors are great, but what if we could pack not just one, but hundreds, or maybe even thousands of them into one tiny, tiny space? The answer to that question is what defined the entire third generation. And that brilliant answer was the integrated circuit, or as we all call it today, the chip. The idea itself was totally revolutionary. Instead of painstakingly wiring individual transistors together one by one, the thought was, why not build hundreds of them along with other components like resistors and capacitors all at once on a single tiny piece of silicon? I mean, this wasn't just a small step forward. This was miniaturization on a whole new level.
Chalo, time for a quick pop quiz. Ready? Okay. Bataiye, what was the main technology used in third-generation computers? Come on, socho, we literally just discussed it. Yes, you got it. The answer is integrated circuits. Dekha? It's these kinds of direct questions that often come up in exams.
So yeah, integrated circuits were definitely the star of the show, but this generation also gave us something else that was huge, the birth of the modern operating system. Think about it. For the very first time, a computer could manage multiple tasks all at once, without a human having to manually switch between them. That's a big deal. Plus, programming became even more accessible with super user-friendly languages like BASIC. So, all thanks to those amazing ICs, computers were now dramatically faster, more reliable, and way more energy efficient than ever before.
All right, now we're arriving at the generation that, well, it changed everything. This is the era that took the incredible power of computing out of these giant corporations and universities and put it right where you and I could use it, on our desks, at home. And this entire revolution was made possible by one single incredible invention, the computer on a chip.
And that incredible technology is the microprocessor. Now, just think about this for a second. If a third-gen integrated circuit had maybe thousands of transistors, a fourth-gen microprocessor packed millions of them onto a single chip. It's just mind-blowing. This wasn't just another component anymore. This was the entire brain of the computer, the central processing unit, the CPU, all crammed onto one tiny piece of silicon. This, my friends, was the true game changer. This is what made the personal computer a reality.
This little microprocessor basically ignited the personal computer revolution. All of a sudden, companies like Apple and IBM could build machines that were small enough and, importantly, affordable enough for regular people. This is also the time when we started to see the first computer networks, planting the seeds for what would eventually grow into the internet we use every day. And on top of all that, powerful new programming languages like C and C++ gave developers the tools they needed to create the software that would literally change the world. And just like that, we arrive at today. Right now, we are living smack in the middle of the fifth generation of computing. And in this generation, the goal has shifted dramatically. It's not just about making computers faster or smaller anymore. Nope. The new frontier, the new challenge is to make them smarter, to give them the ability to think, to learn, and to reason, almost like we do. Yes, exactly. The defining goal of the fifth generation is artificial intelligence, yani AI. You see, for the first 4 generations, a computer's job was just to follow instructions. But the fifth generation, its job is to think, to learn, and to make decisions.
So what are the key features of this generation? Well, one is parallel processing. The easiest way to think about it is like having multiple brains all working on the same problem at the same time, which solves it way, way faster. We also see awesome advanced 3D graphics and something called natural user interfaces, which is just a fancy way of saying we can talk to our devices using voice commands or gestures. And you use this stuff every single day. Every time you ask Siri a question or talk to Alexa or use ChatGPT, guess what? You're interacting with a fifth-generation computer.
Okay, everyone, pay close attention because this is the ultimate summary slide. Seriously, take a screenshot of this or just quickly note it down. This is the absolute core of the entire topic. For each generation, there's one core technology you need to remember. First gen, vacuum tubes. Second gen, transistors. Third gen, integrated circuits. Fourth gen, microprocessors. And fifth gen, artificial intelligence. You have to remember this list. It's super, super important.
So here we are, living in the age of AI. The technology, well, it never stops, does it? So I want to leave you with a question to think about. What will the sixth generation bring? Could it be quantum computing? Maybe direct brain-computer interfaces? Who knows? The possibilities are truly endless. अगर आपको ये वीडियो हेल्पफुल लगा हो तो प्लीज़ लाइक, शेयर और चैनल को सब्सक्राइब करना मत भूलना। सारी PDFs के लिए मेरा टेलीग्राम चैनल ज्वाइन करें, लिंक डिस्क्रिप्शन में है। Keep watching and stay tuned.